How to counter a drone swarm attack. As more countries and organizations understand how swarms can be employed, there is a need to understand how to defend against them. There are several options that can be partially successful to include the use of microwaves, lasers, jamming systems, building underground, and fighting swarms with other drones. Two options deemed to be unsuccessful, whether employed individually or together, are the use of machine guns air defense systems. While both provide the firepower needed to destroy drones, machine guns are restricted in the angles from which they can fire and lose accuracy with increased distance and periods of limited visibility such as nighttime and inclement weather. 17 Meanwhile, air defense systems suffer in their ability to locate targets at low altitude as they are positioned to stop enemy missiles traveling at high elevations. An adept operator can navigate a swarm to fly close to the ground and under an air defense system's monitored airspace. Unlike machine guns and air defense systems, the transmission of radio frequency (RF) energy in the microwave spectrum offers more promising results for swarm defense. The U.S. Air Force Research Laboratory developed the Tactical High Power Operational Responder (THOR), an electromagnetic weapon that can be moved by AC-130 and assembled by two people within hours. THOR emits widespread RF energy, capable of reaching numerous drones in an instant. When this energy reaches a swarm, it overwhelms the circuitry in the drones, causing them to crash. This concept is proven effective in studies with hundreds of drones. Encouraged by THOR's initial results, the U.S. Air Force is looking to expand the technology with a system called Mjolnir, which employs RF saturation over a longer range and with drone detection capabilities. While THOR and Mjolnir efforts are hopeful, they are in their nascent stages of development and may prove cost-prohibitive to poorer countries. A different option being studied by several countries to combat swarms is the use of laser technology. High-powered lasers can heat their targets to the point of component and circuitry failure. When paired with tracking radar, lasing systems can strike targets with great accuracy and severe impact. However, fog, clouds, or smoke can diffuse laser energy in same way they can with light, and reflective surfaces can weaken and redirect laser energy away from a target. The use of lasers will likely be unreliable for militaries in dense weather conditions or low visibility areas. Further, covering drones in a reflective coating may be effective in protecting them from lasers. If such a coating can be applied, it would provide those with offensive swarm capabilities a straightforward way to shield their fleet. A more traditional approach to fight swarms is to use jamming systems to obstruct the radio frequencies that operators use to control drones. This can be especially effective against low-quality drones. When executed correctly, jamming disrupts flight paths, causing drones to stray or crash. Yet, drones can be programmed with inertial navigation to enable them to land or return to their operator if a jamming attempt is identified. Drones with jam-resistant forms of communication are also being manufactured by high-level vendors. Jamming is an affordable countermeasure against basic drones, but that effectiveness will decline against drones with sophisticated resistance capabilities. A passive way to withstand a swarm is to build potentially targeted facilities and weapon systems underground. Traditionally, key facilities and weapons have been placed in secluded areas where they cannot be observed or accessed. With more organizations gaining aerial viewing and imagery capabilities, it is less likely for a site to be identified if it is below ground than remote and above ground. However, building underground requires considerable time and financing, which may be undesirable for an organization that is under a present drone or surveillance threat or lacks funding. An additional method to fight invading swarms is to employ defending drones. Using defending drones can be helpful as they do not have to be synchronized to still be somewhat effective. Defending drones can destroy some of the invading swarm, and they offer the invading swarm more targets which can disrupt the swarm's mission and blunt its attack. Defending drones can be at risk of receiving friendly fire from other defending drones, but if they are inexpensive, the risk is not as impactful. Still, while potentially effective, using defending drones requires operators to be on standby and is unlikely to defeat an entire swarm without the support of other swarm defense systems. There are numerous options to combat drone swarms, but all of them possess notable shortcomings. Countries and organizations under a swarm threat will need to decide which option or combination of options they are willing to accept. In turn, there will be a growing demand for a more decisive and reliable system to defeat offensive swarms. As drone capabilities continue evolving, so too will drone swarms. more foreign governments and non-state actors will likely consider adding swarms to their military arsenal, which will prompt a responsive understanding of how to enact swarm defenses. It is in the U.S. interest to continue monitoring and studying swarms so we understand the changing role they play in the tactical setting and how they can affect our security concerns.